Okay, so when we look at the fractions, this is basically just a sheet of paper divided up, different strips. So you can see the first one is one whole, right? And really, a fraction, all it is a division problem. If you look at the little divide sign, it's a little tiny fraction, isn't it? Okay, so when I say one whole, and I divide it into two equal pieces, each piece is 1/2, right? The numerator tells me how many pieces I have. I have one of them. The denominator tells me how everything was cut up. The original was cut into two pieces, right? As the denominators get bigger, what do you notice about the pieces? They get smaller. So as the denominator gets bigger, the pieces get smaller because we're dividing the same thing into equal parts, smaller, so I divide it up 12 times and then the pieces are really small. That's why like a penny is 1/100th of a dollar. 1/100th of a dollar is a penny. 1/10th of a dollar is a dime, right? So that's the difference there. So we say this is 100th, this is a 10th. And if you had 10 dimes, you're way closer than getting to a dollar than if you had 10 pennies, right? So again, the denominator tells us how many times the original thing was divided up. It was divided into 100 equal pieces. Now, as the numerator changes, that just tells me the number of pieces that I have. So if I have 12 out of 6, and we can actually use these to line them up to find some equivalent fractions. And this kind of helps us understand why we can't add things together that don't have common denominators. If they don't have a common denominator, basically the denominator tells us what the size of the piece is. If I want to add 1/2 and 1/3 together, they're totally different sized pieces. So I don't know what to call that anymore, right? So we use this idea of equivalent fractions. If I line up 1/2, if I use another sheet of paper to line that up, I can see that 1/2 is equal to how many fourths? Yeah, 1/2 is equal to 2/4. I can see that 1/2 lines up with how many sixths? 1/2 is equal to 3/6. And does 1/2 line up evenly with eighths? How many? Yeah, 1/2 is equal to 4/8. 1/2 is equal to how many tenths? 5/10. 1/2 is equal to how many twelfths? Oh, it's not on the page. Okay, 6/12. Now, how do I do that mathematically? If I don't have a picture of what it looks like, what do I have to do to the numerator and the denominator to get the equivalent fraction? I'm going to multiply by, because they're the exact same size, I'm actually going to multiply by 1. So I'm going to multiply by 2/2. 2/2, 2/2. If we look at 2/2, 2/2 is the same thing as 1/2. What happens when you multiply anything by 1? What's the rule? What does that mean? To multiply by 1 means you're going to multiply. Does it change the value? What's your 1 times tables? It's always 1 times anything is itself, right? So what do I have to multiply 2/2 by in order to get 3/6? 3/3, right? Because 3 times 2 is 6, and 1 times 3 is 3. Here, I would multiply 1 times 4 to give me 4, 2 times 4 to give me 8. So if I multiply the numerator and denominator always by the same thing, I'm multiplying it by 1. A lot of people will say, multiply it by 5. No, I'm not multiplying it by 5. I'm multiplying it by 5/5 to give me 1. So, because 5/5 is the same thing as 1. Here, I'm multiplying by 6/6. Now, why can't I make 1/2 equal to thirds? If we look back, the 1/2, it does not line up evenly with the thirds. Because can you multiply 2 by anything to get 3? No. So we say that 3 is not a multiple of 2. All of these ones that I changed the denominator, 2, 4, 6, 8, 10, 12, I'm counting by 2. Those are called multiples of 2. Because I'm going to be multiplying 2 by some number to get the new denominator. Now let's try that same thing with thirds, and we'll notice the same thing. Third cannot be made into a fourth because no natural number, you can't multiply a natural number by by 3 to get 4, right? 4 is not a multiple of 3. So if we look at the thirds, what are the thirds lining up with? They're lining up evenly with the 6s, right? So there's a third, there's a 6th. They line up. How many 6ths? 2 6ths. And that's because we can multiply by 2 over 2. 2 times 1 is 2. 2 times 3 is 6. It also is going to line, does thirds line up with 8ths? It's not. You can see here's the line, and it's cutting the 8. That's because you can't go 3 times 3 to get 8. Nope. Does it line up evenly with 10ths, third? No, because 3 doesn't go into 10. Does it line up evenly with 12ths? Okay. 1/3 equals how many 12ths? 4. And that's because you're multiplying by 4 over 4. 4 times 3 gives you 12. So you can make the fractions have a common denominator you can make them have a new denominator if you can multiply the denominator by a number to give you that new number. So you have to be able to multiply by a natural number, essentially. Okay, so if I wanted to add 1/2 plus 1/3, we see the problem, and that is that they don't line up, and I don't know what to make them into. But they both line up with 6, and that's because 2 times 3 is 6, right? So that 6 is a multiple of 2 and 3, okay? It's actually what we call their least common multiple, or lowest common denominator. So we already proved that 1/3 is equal to 2 6, right? We multiplied that by 2 over 2, right? We already proved that 1/2 is equal to 3 6, right? When we line it up, I see I have 1, 2, 3, 6. So this is 3 6. So, and we multiplied this by 3 over 3. And 3 times 2 is 6. Now if we add these together, if I look at my 6, here's 3 6, which is the same thing as 1/2. If I add to it 2 more 6, which is the 1/3, how many 6 do I have all together now when I add them up? 5. Because they're the same denominator, it means they're the same size piece, 5 6. So if all we do when we add fractions, we have to have the same denominator so that they're the same size. And then the numerator tells us how many do I have, and I just count them up. But I have to have the same size pieces. Okay, let's try another example. Let's say I'm going to add 1/2 plus 1/5. Okay, so I line up my half. I have all these options for halves. Now let's go to 1/5. What can we make 1/5 into? Which one of these denominators does it go into evenly? So you want to make the denominator 5 into a number that you can also make the denominator 2 into. So we have to look at and see which one does it line up with, and that's hard, a little bit hard to see because I'm covering them up, right? But think about your 5 times tables for a minute. Count by 5s. 5, 10, 15, 20. Okay, what we're doing when we list those 5, 10, 15, 20, these are the multiples of 5. If we count by 2, 2, 4, 6, 8, 10, 12. Now notice these multiples go on for infinity. So we're looking for the smallest one. Since the multiples are infinite, we want the smallest one. I don't want to go, okay, 2 goes into 50, 5 goes into 50. I don't want to cut it down so small. Then I'm going to have to glue all those pieces back together, right? So what is the smallest multiple that they have in common? 10. Because see how 5 doesn't have 2, right? So what we call this is the least common multiple, which is the same thing as least common denominator. So if we look at the tenths, half is how many tenths? Oops, 1/2 is up here, lines up with how many tenths down here? 5. Okay, 1/5 lines up with how many tenths? 2. And that's because we multiply by 2 over 2, 2 tenths. So 1/2 gets multiplied by 5 over 5. That gives us 5. 5, what is that? Tenths, yes, good. Plus, what do we multiply by 1/5? 2 over 2, so we really multiply by 1. And we get 2 tenths. And if we add those together, how many do we have altogether? 7 tenths, okay? So one recommendation would be for finding equivalent fractions, and adding and subtracting is really the hardest thing. You can see multiplying happens here. When we multiply fractions, we just multiply across. That's all we do, okay? And so what you can do with this sheet is if you have a blank one like this, you could color in each strip a different color. You could even cut the strips. I wouldn't say cut the small little pieces because then you have too many little pieces around. But you can line them up, and they have to line up perfectly, and then you have to be able to prove it mathematically. What did I multiply? Because you don't want to use this. This doesn't have every single fraction, but it gives you a picture of what it looks like. So you don't want to use it, for every single problem, but when you're getting the used to it, and you're getting the rhythm of how to add fractions, it can be a really good way to line them up, see which ones are actually the same size. And they have to be a perfect fit, right? It can't be just like, oh, that looks close. No, those are totally different sizes, okay? So that could be a strategy. That's how you could use the fraction strips, is just try a few problems. You could even try subtraction. But if we even take the 1/2 and we line it up with the 5 tenths, and then we take the 1/5 and we line it up with 2 tenths, we're going to see that if I add 5 of them and 2 more, I have 7 of them. It makes it really obvious, right? Okay. So that's just a little bit about fractions.